Inside the grand four of La Graufesenque, the air above the 9-story loading chamber shimmers like a desert horizon, bending light into liquid ribbons as heat rolls upward through hundreds of tubuli, hollow clay pipes stacked floor upon floor, each one a chimney channeling 1,000 degrees of fury into 30,000 waiting vessels. A worker standing at the sealed loading door presses his palm flat against the outer stone wall and yanks it back. The masonry radiates heat through half a meter of dressed stone, and sweat evaporates from his skin before it can bead. This is not a potter's workshop. This is an industrial furnace the size of a Roman temple, 11.3 meters long, 6.8 meters wide, and 7 meters tall. And every piece of ceramic inside it represents weeks of labor that will either emerge as the most coveted tableware in the Western world, or shatter into worthless shards before dawn. We begin not here, but 50 kilometers south, in the clay beds that feed this beast. The Tarn River Valley in southern Gaul, in the shadow of the Massif Central, holds deposits of fine-grained secondary clay, material carried downstream over millennia, ground to particles so small they hover in suspension like fog in water. The potters of La Graufesenque, working from roughly 10 Common Era through the early 2nd century, did not choose this location by chance. They needed clay with a very specific chemical fingerprint, rich in illitic clay minerals, high in iron oxide, and critically low in calcium. Elite is a potassium-bearing mineral, and potash acts as a powerful flux. It lowers the temperature at which the surface coating will sinter into a glassy, impermeable skin. Iron gives the finished slip its famous blood-red color under oxidizing conditions. Calcium, by contrast, is the enemy. It opens the microstructure of the coating, making it porous and dull. A potter who digs from a limestone-rich bed will never produce the mirror-bright surfaces that made Gaulish Sigillata the envy of the Mediterranean. Picture the extraction site in early spring, when the ground is soft. Workers drive wooden spades into the exposed bank of a stream bed, peeling back layers of grey-brown earth that smell of wet iron and old leaves. They load the raw clay into woven baskets and carry it uphill to a flat working yard near the workshop compound. Here, the material is spread thin across stone-lined drying platforms, exposed to wind and sun. This is not mere convenience. It is the first stage of a process the Romans inherited from Hellenistic Greek potters and refined over generations. Weathering breaks down the clay's internal structure, encourages bacterial decomposition of organic matter trapped in the mineral matrix, and allows soluble salts to leach out with each rainfall. A clay left to weather through an entire season, spring through autumn, becomes dramatically more plastic, more uniform, and more workable than the raw lump pulled from the riverbank. Once weathered, the clay enters the refining shed for levigation, the critical process that separates a mediocre workshop from an empire-spanning industry. The potters soak roughly 200 grams of dried, weathered clay in a liter of clean water inside large ceramic settling basins, broad, shallow tubs arranged in descending rows along a gentle slope. They stir the slurry vigorously, breaking apart any remaining clumps, then leave it to stand. Gravity does the rest. Within hours, the heaviest particles, sand grains, quartz fragments, feldspar, calcite, settle to the bottom as sediment. Above them forms a denser layer of fine plastic clay, and at the very top, hovering in a milky, almost ghostly suspension, are the clay colloids, particles so infinitesimally small they resist gravity's pull entirely. This upper fraction is the colloidal slip, the sacred ingredient of Terra Sigillata. A worker drills a small hole in the side of the settling basin at precisely the right height and drains the colloidal suspension into a separate vessel, discarding the coarse sediment at the bottom. The middle fraction, the fine clay, is kept for the vessel body itself. Nothing is wasted. now move from the settling yard into the forming workshop, where the air is cool and close, smelling of damp earth and the faintly metallic tang of iron-rich clay. Here, two parallel industries operate simultaneously: the production of plain ware on the potter's wheel and the creation of decorated vessels using molds. For plain forms, the shallow dishes of Dragendorf. Form 18, the small cups of Dragendorf Form 27. A skilled thrower works at a low kick wheel, centering a lump of refined clay body and pulling it upward with wet fingers into standardized shapes. These are not art pieces, they are industrial products, and consistency is everything. A cup that is 1 millimeter too thick at the rim or half a centimeter too wide at the base will not stack properly inside the kiln, and wasted space inside a firing chamber that holds 30,000 vessels is wasted profit. The decorated wares demand an entirely different process. The most characteristic form in the Claudian and Neronian periods is the Dragendorf Form 29, a carinated bowl, meaning it has a sharp angle, like the keel of a ship midway down its profile. Later, from the 70s of the 1st century onward, the hemispherical Dragendorf form 37 overtakes it in popularity, a deep rounded bowl with a plain upright rim. Both are produced using fired clay molds. A mold maker begins with a thick, bowl-shaped blank of clay, its interior surface smoothed to perfection. He then selects from a rack of poinçons, small fired clay stamps, each carved with a single decorative motif: a running hare, a vine scroll, an ovolo egg and tongue border, the figure of Diana drawing her bow, or a gladiator mid-thrust. One by one, he presses these poinçons into the soft interior of the mold, building up a complete decorative scheme in intaglio, hollowed impressions that will appear as raised relief on the finished bowl. Some freehand work with a pointed stylus adds fine details: tendrils connecting the vine scrolls, ground lines beneath the figures, the feathery edge of acanthus leaves. When the design is complete, the mold is dried slowly, trimmed, and fired to hardness. The pressing of a vessel from this mold is a deceptively simple act. A potter takes a measured ball of refined clay body, not the colloidal slip, but the denser fine middle fraction from the levigation, and pushes it firmly into the interior of the fired mold, working outward from the center with his thumbs, forcing the clay into every poinçon impression, every stylus groove. He must apply even pressure. Too much in one spot, and the wall thins dangerously. Too little and a figure's face blurs into anonymity. As the pressed clay dries, it shrinks, and this shrinkage is the ingenious mechanism that allows the bowl to release cleanly from the mold without distorting the decoration. The potter lifts the raw bowl free, trims its upper edge on a slow wheel, and attaches a foot ring to the base, a low, neatly turned ring of clay that allows the vessel to sit flat and stable on a table. Many potters then press their name stamp, or sigillum, into the interior floor of the vessel. Names like Calvus, Scotius, Primus, or the partnerships of slaves working under a single workshop owner. These stamps sometimes include the abbreviation F, FE, or FEC, short for Fecit, meaning he made it, or M and MA, for Manu, by the hand of. These are not signatures of pride alone. They are accounting tools. In a factory producing tens of thousands of pieces per firing, every bowl must be traceable to the man who formed it. Now comes the moment that transforms dull, chalky clay into the jewel-red surface that Roman officers, merchants, and provincial elites will pay premium prices to set upon their dinner tables. The dried, trimmed, stamped vessel is carried to the dipping station, a long trough filled with the colloidal slip, harvested weeks earlier from the settling basins. The potter grips the vessel by its foot ring, inverts it, and plunges it smoothly into the slip, submerging it completely for a count of 2 or 3 heartbeats, then withdrawing it in a single fluid motion. The coating must be gossamer thin. A thick application will craze and flake after firing. On some surviving vessels, archaeologists can detect faint overlapping tide marks where the slip pooled slightly during dipping, evidence of real human hands working at speed. The dipped vessel is set upright on a drying rack in the open air. As the water in the slip evaporates, the ultrafine illitic particles bond to the vessel surface through electrostatic attraction, forming a skin so smooth it will sinter into a near-glassy finish in the kiln without any polishing or burnishing whatsoever. This is the critical distinction between true Terra Sigillata and lesser imitations. The quality of the colloidal slip is so refined, so perfectly particle-selected, that the fired surface achieves a mirror-bright gloss by chemistry alone. But the colloidal slip's potential extends beyond uniform red. During the mid-1st century, the potters of Graufesenque, and only Graufesenque, experimented with a technique called marbled Terra Sigillata. They applied 2 different colloidal slips simultaneously, one iron-rich red, one calcium-modified yellow, and swirled them together on the vessel surface before firing, creating a polychrome marbled effect of red and golden yellow streaks locked beneath a glossy finish. This variant never achieved mass popularity and was abandoned within a few decades, but its very existence reveals a workshop culture of experimentation, of potters pushing the boundaries of a chemistry they understood empirically, even if they could not name the minerals involved. The dipped and dried vessels must now survive the kiln. And the kiln at Graufesenque is unlike anything else in the ancient world. The Grand Four, the Great Kiln, excavated at the site and dated to the late 1st and early 2nd century, is a rectangular stone-built furnace of staggering proportions. Its external footprint stretches 11.3 meters in length and 6.8 meters in width. Its estimated original height reaches 7 meters, taller than a 2-story Roman insular apartment block. Inside this chamber, workers construct up to 9 temporary stories before each firing. The floors of each story are laid from flat ceramic tiles, and the vertical supports that hold them apart are tubuli, hollow clay pipes, or tubes that serve a dual purpose. They bear the structural load of thousands of stacked vessels above, and they act as heat conduits, channeling hot gases from the combustion chamber below upward through every level of the kiln. Without these tubuli, the uppermost floors would receive only a fraction of the heat, reaching the lowest, and the firing would be catastrophically uneven. Loading this kiln is a logistical operation that takes days. Each of the 9 stories must be carefully stacked with vessels arranged by size. The largest, heaviest pieces on the lower floors, where temperatures are most intense, graduating to smaller cups and dishes near the top. The vessels cannot touch one another. The sintering colloidal slip is sticky during firing, and any contact point will fuse 2 pieces permanently into a useless lump. Workers crawl through the loading door, a lateral opening in the kiln wall, sealed with small adobe bricks, and a slurry of sifted earth and water, once loading is complete, and arrange each vessel by hand, thousands upon thousands of them, until the chamber is full. The documentary evidence is extraordinary. Fired clay tallies, or graffiti, discovered at Graufesenque, record the contents of individual kiln loads. These lists, inscribed on stamped dishes and fired alongside the cargo they describe, name each contributing potter and the number of pots he has consigned to the firing, and the totals regularly reach 25,000 to 30,000 vessels in a single load. The firing itself is an oxidizing process, straightforward in principle, terrifying in execution. The combustion chamber beneath the kiln floor is fed with wood fuel, likely local oak and pine from the forested slopes of the Massif Central. Workers feed the prefernium, the stokehole, the mouth of the furnace, continuously, maintaining a steady climb in temperature of roughly 100 degrees per hour. The target is approximately 1000 to 1050 degrees. The narrow window in which the colloidal slip sinters into its characteristic glassy red finish. Below 900 degrees, the slip remains porous and dull. Above 1100, it begins to bubble, blister, and lose its gloss. Oxygen must circulate freely throughout the firing. This is not the reduction atmosphere used by Greek black figure potters, where carbon monoxide steals oxygen from iron oxide to turn it black. Here, the iron in the slip must remain fully oxidized. As hematite, the mineral responsible for the vivid red. Recent scientific analysis has revealed that the color of Terra Sigillata is not merely a function of iron oxidation state, but depends on the crystal size of submicroscopic hematite and corundum particles, suspended within a glassy matrix of silicon and aluminium oxides. Large hematite crystals appear black. As the crystal size decreases to submicron scales, the color shifts to brilliant red. The potters of Graufesenque, without microscopes or spectrometers, learned to control this nanocrystalline chemistry through the empirical mastery of raw material selection, slip preparation, and firing temperature. A firing of the Grand Four lasts many hours, possibly overnight. The heat is monitored not by thermocouples, those are a modern invention, but by test pieces. Small sample sherds of slipped clay placed near viewing ports in the kiln wall, hooked out periodically with an iron rod to check the color and surface quality of the developing gloss. When the master potter judges the temperature correct, the slip on the test piece has turned from chalky pink to glossy, saturated red. The stoking ceases, and the kiln is left to cool. This cooling phase is itself critical. A too rapid drop in temperature will crack vessels by thermal shock. A kiln this massive retains heat for days, and patience is not a virtue, but a structural necessity. When the loading door is finally unsealed, and the first rush of cooler air meets the residual warmth inside, the workers who crawl in are greeted by a sight that justified every hour of labor. Tier upon tier of gleaming red vessels, their surfaces catching torchlight with an almost metallic sheen, stacked in their thousands across 9 floors of the now dismantled story system. Each tile floor, each tubulous column, is broken apart and discarded. They are single-use infrastructure, rebuilt fresh before every firing. The vessels are unloaded, inspected, and sorted. Wasters, pieces that cracked, warped, fused together, or emerged with dull, underfired surfaces, are smashed and discarded in the workshop's dump pits, where archaeologists would recover them nearly 2,000 years later as invaluable evidence of production failures and the relentless quality control these workshops imposed. The finished Terra Sigillata now enters the distribution network that made Graufesenque one of the most commercially successful pottery operations in the ancient world. By the mid-1st century, South Gaulish Samian ware had displaced Italian Aretine ware across the western provinces, and Graufesenque's products traveled not only north to the military frontiers along the Rhine and into Britain, but south into the Mediterranean, east into the Danubian provinces, and even back into Italy itself. One of the most dramatic proofs of this reach was found in the ruins of Pompeii, destroyed by the eruption of Vesuvius in 79 Common Era. A consignment of South Gaulish sigillata, still sealed in its wooden packing crate, frozen in transit at the moment the volcano buried the city. These vessels had traveled more than 1,000 kilometers from a hillside workshop in southern France to a merchant's storeroom in Campania, and they were considered valuable enough to ship across the sea. The potters who made them, Calvus, Scotius, Cosius, Primus, and dozens of others whose stamps survive on fragments scattered from Scotland to the Sahara, were not anonymous laborers. Their names, pressed into the wet clay of every vessel they formed, functioned as brands in a market that rewarded consistency and punished defects.
These tallies
A
represent
buyer in
30,000
Londinium or
vessels,
Colonia,
each stamp
who
here is an
recognized the
agreement
stamp
to
of a
reputable
trusted
made
potter,
what
knew
survived the
exactly
fire.
what quality of slip, what precision of form, what reliability of decoration to expect. The stamps also served internal accounting within the workshop. When a kiln load of 30,000 vessels was shared among dozens of contributing potters, the fired tallies recorded exactly who owed what to whom, and whose work had survived the fire. By the late 1st century, as the Flavian dynasty gave way to the Antonines, production at La Graufesenque began its slow decline. The central Gaulish workshops of Les Eaux and Les Martres de Verre, closer to the northern markets and the military frontier, rose to dominance in the 2nd century. The forms grew heavier, the decoration coarser, the vessels thicker walled, a drift towards shapes that were easier and quicker to produce at the expense of the razor-sharp profiles and luminous slips of the Claudian Golden Age. The East Gaulish factories of Trier and Rheinzabern took over in the later 2nd and 3rd centuries, and the tradition of mold-made relief decoration gradually faded, replaced by simpler barbotine and incised techniques. By the early 4th century, Terra Sigillata, as the Romans had known it, that extraordinary fusion of industrial-scale production and nanoscale material science, had effectively ceased, but stand inside the excavated footprint of the Grand Fort at La Graufesenque today, and the scale of the achievement is still palpable. The stone walls still rise from the earth. The channels where tubuli once stood are still visible in the foundation, and in the museum nearby, the fired tallies, those fragile clay documents listing potters' names and vessel counts by the thousand, still carry the fingerprints of the workers who inscribed them, pressed into the wet clay surface as casually as a signature on a receipt, nearly 2,000 years ago. 30,000 vessels, loaded by hand, fired by instinct, cooled by patience, and shipped across an empire, not by machines, by men who understood fire.